Okay, so last night I didn't give you any written homework because most of the questions on these changes to the whole function and changes to the angle, so changes to both the range and the period tend to be asked in the same question. So I wanted to go through these examples before I gave you some written practice. Okay, so yesterday we were looking at what happened to sine and cosine if we multiplied the whole function. So multiplying cosine itself or multiplying sine itself. Now we're going to look at what happens when we multiply the angle. Okay, so this is not multiplying sine. You multiply the angle and then you find sine of the answer. And the period and the range are going to be important as well. So I think even just looking at the graph, you can see what happens. The red graph here is the graph of sine of x, and the blue graph beside it is the graph of sine of 2x. Sine of 2x, what happens when we multiply it? So when you would normally find sine of 30 degrees, now you're finding sine of 60 degrees. When you would normally find sine of 45 degrees, now you're finding sine of 90 degrees, and so on and so forth. So we can do our input-output table as usual. And what you'll see, what you'll notice is that sine keeps its same shape and it still goes between 1 and -1, but it starts to repeat more frequently. Previously, we had one full wave tucked inside 0 to 360 degrees. Now we have one full wave tucked inside 0 to 180 degrees. So what we can see is that when you multiply the angle, you change the period. Change how frequently it repeats. And how do you change it? Well, basically, you divide the period, you divide the standard period, 360 degrees. So the new period will be 360 degrees divided by the number that multiplied the angle. So if I have sine of 2x, then the period is going to be 360 degrees divided by 2, because there's a 2 in front of the x, and that is 180 degrees. The amplitude, which is how high up it goes and how far down it goes, the amplitude or range doesn't change. So again, if I have sine of 2x, the range is still -1 to 1. The range is still -1 to 1. Let's stick in another few examples. If I have sine of 3x, then the period is going to be 360 divided by 3, because it's the number in front of the angle, which is 120 degrees. So you'd find that if I was sketching sine of 3x, it will still go all the way up to 1 and -1, but it will repeat within this. So it'll go like this. That's what we'll get, and it'll keep repeating like that. So we'll go up here as well. And what you'll find is where you usually would have had 2, you now have 3. So this would be sine of 3x. What happens if you multiply it by a fraction? Again, the range doesn't change. The range is still -1 to 1. What if I had sine of half x, or x over 2? So we can also write sine of a half x as sine of x over 2. And sometimes we put in the brackets and sometimes we don't. So I said the rule is that the period will be 360 degrees divided by the number in front of the angle. And when you divide by a half, you multiply by 2, you get 720 degrees. So it would be stretched out even further. We'd only get half of the wave function drawn in the 360 degrees space. And again, the range would not change. The range will still be -1 to 1. Okay, so that's what happens when you multiply the angle. So we'll just make a quick note here. When you multiply the function, the sine or the cos, I can't seem to write today, sorry. When we multiply the function, the whole sine or the whole cos, you multiply the range. That's the first kind of thing we do. The second thing we do is that we might multiply the angle, the x value or the theta value, and that means we divide the period. So that's the second thing that we do. So those are the two things that we do. Let's take a look at it with cosine as well. Exactly the same kind of thing again. And just for illustrative purposes, we did cosine of 3 times x here. So we're going to fit 3 whole cosines into the space that we had here. This was cos of x, and this was cos of 3x. This blue one here was cos of 3x. And we know the range hasn't changed, so when I have cosine of 3x, my range hasn't changed. It goes from -1 to 1. But my period, just like with sine, is 360 divided by the number in front, which is 120 degrees. Now I said that, okay, I didn't say anything. You might be wondering what happened to tan, and we don't do these things to tan with their graphs. Like we might multiply tan and we might multiply its angle as well. And the same thing will happen in terms of the period, but the range for tan of x is -infinity to infinity, because if you remember the graph of tan, it goes shooting off in both directions. So we don't usually do these with tan of x. Let's just stick in another one here. What if I had cosine of, let's say 1/3 of x, cosine of x over 3. Then the range is going to remain at -1 to 1, and the period will be 360 divided by 1/3, which is the same as multiplying it by 3, and we get 1080. So it'll get really, really stretched out. In terms of plotting that, you'd need to have more space on your x-axis. Okay, so that's it, guys. We're actually finished. Well, we're nearly finished trigonometry. We need to finish proving the formulae. So things we have to finish. We're going to finish proving the formulae. And there are a few examples at the back for using those formulae. So I'm not going to do those in one go as part of trigonometry. This one hardly ever comes up in the exam papers. I do want to complete it though. So we're just going to do these for one of our 2 classes on Fridays. So Fridays only. I do want to practice with some exam paper questions for trigonometry because they can be very confusing in how they're They're asked. It can come up on both paper 1 and on paper 2. It's one of the few topics that comes up on both papers. So we're going to practice a few exam paper questions before we move on to functions. So functions is the next topic that we're going to start then. Okay, thank you very much.